Hi. So we have to talk about the definition of the derivative. And the derivative of f of x at x equals c is going to be represented by these two expressions. So what they essentially are, the expression here is what we call the difference quotient. This is the change in the y value divided by the change in the x value as the change in the x value becomes 0, because as x approaches c, this will approach 0 and this will also approach 0. This notation here is another way to write the same thing, because delta x represents the change in the x, which is going to approach 0, and the expression f of c plus delta x minus f of c will also approach 0 as delta x approaches 0. So these two expressions represent the same thing, the derivative. They also represent the instantaneous rate of change at x equals c. Geometric interpretation of the derivative is the slope of the tangent line to the graph. And if you do not want to find it at a particular point, just want to find the derivative in general, then the formula that we use for that is going to be this formula. So the difference between this one and this one is that we do not use a specific value of c here, we just use x. Let's see how this works. So we're going to take a look at this. We got f of x equals x squared minus 5, and we want to find the slope of the tangent line. The moment you see word slope of the tangent line, you should immediately think the derivative. So we're going to find it using two different methods, using two formulas. So we're going to start by setting up the limit as x approaches 3 of f of x minus f of 3 divided by x minus 3. So we have those things. So f of x is x squared minus 5. F of 3 will be taking 3, substituting it in here, which will give you 9 minus 5, that's 4, divided by x minus 3. Continue with this. So we have the limit as x approaches 3. This is going to be x squared minus 9 divided by x minus 3. This is still 0 divided by 0 if you attempt to substitute that. So what we are going to do is we are going to see if we can use one of those methods for finding the limits. You can actually do dividing out. You can factor the numerator as x minus 3 times x plus 3 divided by x minus 3. So you can see that the part with x minus 3 is going to cancel. And then you're just going to have the limit as x approaches 3 of x plus 3, and direct substitution here gives you 6. Okay, the other method, we just want to show you that the other method will produce the same result. So here we're going to have delta x approaches 0 of, this is going to be f of 3 plus delta x minus f of 3 divided by delta x, and delta x approaches 0. So it's a little bit more advanced algebraically. Well, I shouldn't say advanced, but it requires a little bit more effort here in understanding. So we are going to substitute 3 plus delta x into the function, which will give us 3 plus delta x squared minus 5 minus, and this is simply going to be f of 3, which we already know is 4, divided by delta x. So continue with this. We're going to have to distribute all this. So it's the limit as delta x approaches 0 of 9 plus 6 delta x plus delta x squared minus 5 minus 4 divided by delta x, right? So you can see that 9 and minus 5 minus 4 will cancel. After that we have delta x. Both terms on top contain delta x, so we are going to factor it out. So we have the limit as delta x approaches 0. We factor out delta x. That's going to leave us with 6 plus delta x divided by delta x. After that, delta x cancels. And basically gives you 1. And then you're just going to have 6 plus delta x. When delta x approaches 0, you are going to get 6. So we get the same answer. I'm not going to use this formula with these problems, with the next few problems, because the first one's a little bit easier. Alright, so let's continue. Well, find the slope of the tangent line. Again, as I mentioned earlier, these words here are an indication that the derivative will have to be found. So, the limit as x approaches negative 1 of g of x minus g of negative 1 divided by x minus negative 1, right? So this is going to become the limit as x approaches negative 1. G of x is x squared plus 3x. G of negative 1, when we substitute negative 1 into the expression, this is going to be 1 minus 3, so negative 2. So minus negative 2 divided by x approaches x plus 1, right? So this is going to give us in the numerator x squared plus 3x plus 2 divided by x plus 1. If you try to substitute negative 1, it is still 0 divided by 0, so we are going to use dividing out. That is going to work here. So this is x plus 1 times x plus 2 over x plus 1. So x plus 1 is going to cancel. We're just going to be left with x plus 1. So x plus 2. And we substitute that, we are going to get 1. This next problem, find h prime. This is the derivative. It's a little bit more direct. As x approaches negative 1 of h of x minus h of 1. So it's positive 1 over x minus 1. So the limit as x approaches 1 minus 3x. When you substitute 1 into this expression, that is going to give you 1 minus 3, which is negative 2, divided by x minus 1. So this will give us the limit as x approaches 1 of 3 minus 3x divided by x minus 1. So factor out 3. So it's 3, 1 minus x over x minus 1. So you should notice here that x minus 1 and 1 minus x are the opposites of each other. So you can cross them out, but when you do, don't forget there's going to be a negative 1 left, because that's what happens when you divide the opposites. And we continue, going to get the limit as x approaches 1 of negative 3, which is negative 3, of course. I do want to point out that the function h of x in this case is a linear function, so the slope is a constant value here, and the slope of this line here is negative 3, and we actually ended up with the derivative being negative 3. That is not any coincidence. This is actually the way it's supposed to be. Alright, moving on. So this expression here, the function is 1 over x, find f prime of 2. So the limit as x approaches 2 of 1 over x minus 1 over 2 divided by x minus 2. We do have to work with that complex fraction a little bit. So we have limit as x approaches 2. So when we simplify the numerator, it's going to be 2 minus x over 2x divided by x minus 2, which in turn I can rewrite as 2 minus x in the numerator times over 2x x minus 2. Again, 2 minus x and x minus 2 are opposites of each other, so when you cross them out, they are going to leave you with negative 1. Right? And I think you can see at this point that there is no issue with direct substitution. You have negative 1 over 2x, x becomes 2, and it's going to become negative 1/4. Okay? Example 5, we have a square root of x plus 2 as our function. So, limit as x approaches 2 of square root of x plus 2 minus, when we substitute 2 in here, that's square root of 4, which is 2, divided by x minus 2. So this is still 0 divided by 0. You get a 0 on top, 0 on the bottom. So what we can do here is use one of the other methods that you know, which is rationalizing. So we're going to multiply the numerator by the conjugate. Now it's going to get a little busy for a little bit, but we'll get through that. The limit as x approaches 2. So the numerator is difference of squares. That's going to give you x plus 2 minus 2. I'm sorry, minus 4. Right? The denominator is going to give you x minus 2 times this radical expression. So the numerator is going to become, this here is actually x minus 2, right? And then you can see that x minus 2, so, and x minus 2 on the bottom, so this expression here and this expression can cancel. That means you are going to end up with the limit as x approaches 2 of 1 over the square root of x plus 2 plus 2. There is no longer any issues with 0 divided by 0. You can actually use direct substitution. The numerator is 1. The denominator is going to be square root of 2 plus 2, that's 2, and it's going to give you 1/4. Okay? Alright. So here is where we're going to have a problem where you just need to find the derivative. There is no specific value that you're going to be using for x. So x is going to stay x. I'm going to show you really quick the formula we're going to be using. We're going to have to use this formula because we don't have a specific value for x. So that's the only formula that you are going to be able to use here. Let's go ahead and start. And that is the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. So it's going to get a little bit busy for just a few seconds because you're going to have to plug in x plus delta x into every place where x is. So this is what it's going to look like. It's going to be x plus delta x squared minus 2 times x plus delta x plus 3 minus the function itself over delta x. Now it's going to get even busier because we're gonna have to expand all that. So it is the limit as delta x approaches 0 of. Alright, here we go. This is going to give you a trinomial, which is going to be x squared plus 2x delta x plus delta x squared minus, distribute the 2, so minus 2x minus 2 delta x plus 3, and then minus x squared minus plus 2x minus 3. So one important thing for doing this particular over delta x is that if this is done correctly, all your terms that do not contain delta x are supposed to cancel. Let's see. We got x squared, it cancels the negative x squared. We have negative 2x and positive 2x. We got positive 3 and negative 3. So let's take a look. We have delta x here, and delta x here. Okay, that is supposed to be that way. If something is not like that, then you do need to check your algebra. Algebra for these problems is key. So limit. So we have every term is going to contain delta x, which means I can factor it out. It's going to leave me with 2x plus delta x minus 2 over delta x. Okay, so delta x and delta x are, you're going to cross them out. And now there is no quotient anymore, which means there shouldn't be any issue with direct substitution. Delta x becomes 0 and your answer is going to be 2x minus 2. It is something that you should expect here because you don't have a value for x, and that means you are going to have something with x in it. But please remember, the nice thing about this, now that we have this expression, we can evaluate this derivative at any point we want. We can simply take any number and find it this way. Okay. One more example for us to do. So find g prime of x, as if g of x is 3 over x plus 1. So we're going to have to set it up the same way. A limit as delta x approaches 0. So it's going to be 3. We're going to have to plug in, well, let me write this first. So we have to plug in x plus delta x for x in this function. The limit is delta x approaches 0 of 3 over x plus delta x plus 1 minus 3 over x plus 1 all over delta x. So these two fractions need to be combined. So their common denominator is the product of these two. It's going to be a little bit challenging for a moment, but with good algebra skills that should not be a problem. This is going to be 3 times x plus 1 minus 3 times x plus delta x plus 1 all over x plus delta x plus 1 times x plus 1, and then all over delta x. So what we really need to do is we just need to drop this line here down. So let's rewrite it first. So it's all over delta x times x plus delta x plus 1 times x plus 1. Okay. And now let's work out the numerator, because that's the one where we can simplify things. So it's 3x plus 3 minus 3x minus 3 delta x minus 3 over all that scary looking denominator. Don't worry about it, it's not really that bad. So, as I mentioned with the previous problem, if this is done correctly, all your terms without delta x must cancel. So we got 3x and negative 3x, we got 3 and negative 3. So the only term on top it has the delta x. So if I rewrite that, let me rewrite that to make it a little bit less scary. So we have negative 3 delta x in the numerator over delta x times x plus delta x plus 1 times x plus 1. So you can see that delta x and delta x are going to cancel each other. And you don't have that anymore. And actually now is no longer any issue with an indeterminate form. So it's the limit of delta x approaches 0, negative 3 over x plus delta x plus 1 times x plus 1. And now if you make delta x equals 0, that simply cancels this term here. And what you are going to have is negative 3 divided by x plus 1 square, which is the expression for the derivative of that function. And again, just like with the previous problem now, if you want to evaluate this derivative at any particular x value, just substitute that x value into this derivative and you get your value. Okay? I hope this helps.